In this last question, this is a unfinished question from the 3.5 lesson where I asked you to find how much water a plant creates through photosynthesis. Now, the balanced chemical equation is already provided in the question, so I'm not going to go through the balancing process. For those of you guys who aren't in bio, photosynthesis is the process by which plants convert sunlight into energy. Like all living things, plants like to create glucose, which is a sugar that it uses to do all of its planty things like make new cells and be green and yeah, like those things. Again, I'm not a bio teacher by any stretch of the imagination, so I'm sure some of you guys know a lot more about this process than I do. So we've got a little bit of a simpler one here. It should be a bit more straightforward for those of you guys who maybe found the last question to be a little bit daunting. In this question, essentially a plant produces 15.6 grams of glucose, and the question wants to know how much water it had to consume to produce that much glucose, specifically in grams. Now, as you can see, there's no molecules, no particles, nothing like that referenced in the question, so we're not going to have to worry about Avogadro's number, but we certainly should calculate the molar masses of the two chemicals that the question is referencing specifically, which is the glucose, which is C6H12O6, as well as water, which is H2O. So I'm just going to push this page up here, get this all looking nice, and then I'm going to use my magic pencil to just make the numbers appear right here. Oh, abracadabra, there are the numbers we're talking about, the 2 molar masses there. And the other thing I need to write down is the quantity the question gives me, which is that 15.6 grams of glucose were created in the reaction. Looking good. And as always, to form our equation, we're always going to start with what the question is asking us to actually find, which is how many grams of water were consumed. So I'm going to go grams H2O to get started. Now, much like every time with unit elimination, we're going to start with the quantity that we're given that has just a single unit, which is 15.6 grams of glucose. Now you'll probably notice I'm being very specific with my units, even in the equation. I'm even including the identity of that unit because I have grams of water and grams of glucose. I need to be able to differentiate between those two things. So I know it's kind of burdensome to write all those things down all the time, but it's going to save you a lot of pain in the end when you include those units, especially if you run into a mistake, because it'll be easy to backtrack and figure out where you might have screwed up, or it'll also be easier to go over your questions and see what the process was that you went through to get there. Now, so I need something with grams of glucose in the bottom, and of course I'm going to go straight to the molar mass here. I'm going to go straight to the molar mass here, which is 180.1566 grams. I'm going to put that in the bottom because I want to cancel out grams of glucose with 1 mole of glucose on top. Yeah, that should let me cancel that out with that, leaving me with moles of glucose. All right. Use that. Now again, there's nothing here that has moles of glucose in them. I have moles of water. That's not going to help me cancel out moles of glucose. So that's going to bring me to my stoichiometric ratio up here. And I know that 6 moles of water had to be used to create every 1 mole of glucose. So I can multiply this by 1 mole of glucose in the bottom and 6 moles of H2O in the top. Reflecting again these two molar ratios here, the 6 on the H2O and the nothing on the C2H12O6, which is basically a hidden one that we don't show. That'll cancel moles of glucose with moles of glucose here, but I got moles of water, I want grams of water. So again, molar mass is going to help me convert those. I'm going to have to put grams of water in the top this time. I'm running out of space. Just enough space. It just barely fits. My moles of water and my moles of water are going to cancel out, That's going to leave me with grams of water, which again is what I wanted to find at the start of the question. So I should at this point be able to just math it and put the numbers in that I need based on what's left over, punch it into a calculator, and figure out what the grams of water is in the end. So I've got the 15.6 grams that was at the beginning. I'm going to divide that by the 180.1566. That's going to get multiplied by 6. And then that's going to get multiplied by 18.0153. Again, you'll notice that all the ones I kind of just ignore because dividing and multiplying by 1 doesn't change the value. Let's put the answer right here using magic. Oh wow, that one came with all the bells and whistles. Almost an entire therefore statement. It's good to go. So what that means, basically, we make 15.6 grams of glucose and 9.36 grams of water needed to be consumed to create that. Presumably to provide the glucose with the hydrogens and oxygens required to change a carbon compound into a complex sugar compound that a plant can use to break down and turn into other things. All right, that's the end of this week's video lessons. If you have any questions, email me anytime. I can understand that unit elimination can be a bit daunting, but it really does boil down to practice. And the more practice questions you do, the more different types of questions you try, the easier unit elimination is going to get, because it really is always the same set of steps. Start with the quantity, cancel that quantity out. Now you got a new quantity, cancel that quantity out, and keep going until eventually you end up with the quantity that you're looking for. And as I said, this method can be applied in basically any area of lab chemistry. It's very handy. I use it when I make your labs, and I mix chemicals for your labs with certain concentrations and masses and amounts. So it's a very useful thing if you plan on ever working in any science lab. So practice it. But as I said, if you have any problems, drop me an email anytime. I'd be glad to go over any questions you might have with you one-on-one. I'll do it on a piece of paper. I'll send you a picture, whatever. Just let me know. Hope you enjoy your week. And when you're ready for your quiz, feel free to drop me an email at any time. Bye-bye.